Hey guys, okay, welcome to yet another video on forces. Alright, so just to recap from our last video, we talked about what can forces do. So forces, as you can see here, two main things they can do. They can change an object's motion or they can actually change its shape. Alright, so let's look at how does a force change the motion of an object. Okay, you can see from this video here, these images here, that the forces actually in this case it either slows it down or you can, as you can see, speeds it up. Okay, another thing that forces can do, it can change the direction. So in other words, you can either accelerate, decelerate, or um, changing the direction, so the velocity changes. Okay, so what are the effects of a force again? So effects of a force, you can see applying a force, like what we saw just now, can cause an object to accelerate. So how does it for a body actually accelerate? Accelerate means in a stationary object, you can cause it to start moving, or a moving object to increase its speed, or to decrease its speed, and finally to change its direction. Okay, so you can see all these are actually cases of scenarios for acceleration. So when acceleration is zero, that means when there's no acceleration, does this mean that there is no force? Okay, before we look at that, let's look at what does zero acceleration mean first. Okay, so zero acceleration, from the definition of acceleration, a equals v minus u over t. You know previously the formula for acceleration. Okay, so if we were to substitute the acceleration as zero, you can see 0 equals to v minus u over t. Bring t over, t times 0 is 0, so 0 equals v minus u. And finally, what do you get? Boom! I get v equals to u if I bring the u the other side, right? So zero acceleration means constant velocity. Okay. Okay, so zero acceleration again means constant velocity, and constant velocity I can have two cases. All right, constant velocity can mean it is not moving or moving. Okay, so when it's not moving, the constant velocity is zero, or if it's moving, the constant velocity of any number. All right, so does this mean that there are no forces? No, it doesn't really mean that there are no forces. It only means that the resultant force is zero. Okay. All right, so just to recap on what we've covered so far. So if there's no resultant force acting on a body, we know that there will be no acceleration, and no acceleration means no change in velocity. So, as we can saw previously also, no change in velocity can mean two things. It means it's either remaining at rest or it remains at constant velocity. You can see here, an apple is at rest, not moving, but it's moving to the right, in this case, with constant velocity. So, converse is also true. What do we mean by that? That means if I see an apple at rest, or I see an object, an apple, moving at constant velocity, in this case, okay, we know straight away that there is no resultant forces. Okay, we can tell that. Clever, eh? Okay, so just to illustrate that idea again, as you can see this apple here, both of these are moving at constant velocity. One is at moving constant velocity, the other one is not moving at constant velocity. So both of them are at zero acceleration. So what does that mean? It means no resultant force. So how do you see any resultant? How can you tell here? It means that whatever force that is pulling it, it will be a zero resultant force over here. Again, 3 minus 3 is 0 resultant force. So 0 resultant force basically means that forces are balanced. That, in a nutshell, is Newton's first law. Okay? So now we just go into Newton's second law. Looking at this, okay, we have in outer space, we have three objects being pulled by different forces. Which one you think will move the fastest, will accelerate the fastest? Okay, check this out. Boom. Okay, so the one with the largest force will move the fastest. Okay, all right, so why is that so? Okay, the bigger the force, the greater the acceleration. All right, so what if I were to have another scenario? Okay, same force but different objects. Which one will have the greater acceleration? In three, two, one, boom. Okay, you can see the one with the lighter mass will undergo higher acceleration. So what does this mean? The smaller the mass, the greater the acceleration. Makes sense, right? Okay, so this brings us to this relationship. Basically, acceleration is proportional to force, inversely proportional to mass. Okay, so from the previous two animations, you can see if I have a larger resultant force, the first one, it shows me will result in a larger acceleration. Okay, what about masses? Okay, a larger mass, since it's in the denominator, will result in smaller acceleration. Okay, makes sense? Nice arrows I've got there. All right, so that relationship again. What does that mean? If this results in my final uh, relationship. So the relationship that we are all familiar with is resultant force equals mass times acceleration, or also known as F equals ma. Okay, now we come to the third and final law in Newton. Okay, basically when an object exerts a force on the second object, the other object will exert an equal and opposite force on the first. So basically, forces always occurs in pairs, and the pairs will always have equal and opposite reaction. Okay, now what does this mean? You can see here, if we have a finger poking a pin, you can see the force of pin acting on the finger feels pain because the force that's pushing in, and the same amount of force will actually be acting on the pin. So it's a force of finger acting on the pin. You can see both these forces are on opposite bodies. One is on the finger, one is on the pin, and they are both exactly equal in magnitude at all times. Okay. Another example here, I will just show you. Okay, how does a rocket keep in flight? Okay, because if a rocket, if it burns fuel, there will be a forces of gases acting on the rocket, and the other object will be the gases. So the rocket will also exert force on the gases. Okay, so both these you can see equal and opposite. Okay, another scenario here. I have two guys on a skating rink. You can see blue and red. Once blue actually starts to push, he doesn't just feel a force. Red doesn't just feel a force on him, but blue will feel exactly the same amount of force on him, and that's why they both have an equal and opposite force acting on each other. That's why they start to accelerate. Okay, another final one. You can see blue is right now lighter, has a smaller mass than red. So what do you think will happen? So since both the forces acting on each other will be the same, both of them will have the same force acting on each other using Newton's second law. What do you think will happen? Yes, you can see red will undergo lower acceleration. Okay, this is based on the relationship force equals mass times acceleration. Okay, so hope you enjoyed this video on Newton's three laws. So just a quick summary on the three laws that we've covered so far. First, we have Newton's first law, which is basically on balanced forces. When the forces are balanced, means resultant force is zero. You can see acceleration zero. Acceleration zero, there are two cases. It means it's either at rest or moving at constant velocity. Okay, Newton's second law will be on unbalanced forces. Unbalanced forces means resultant force is not zero. It means that is acceleration. Okay, acceleration cannot be zero. Okay, so in other words, object at rest will either start moving or change the velocity. In other words, it will either accelerate or decelerate. Okay, and Newton's second law is covered by this relationship F equals ma. Alright, hope you enjoyed this video on Newton's three laws. Alright, I'll see you in the next.